Let's talk about completing the square, right? This allows us to solve using the square root property, right? This allows us to pull a binomial apart into a perfect square. So if x squared plus bx is a binomial, if I add my middle term's coefficient b divided by 2 squared, right, I'll be able to factor this as a perfect square. So this would allow us to use our square root property. So let's go ahead and complete a few squares. So if I have x squared plus 8x, I'm going to want to add my b term divided by 2 squared. So I'd have x squared plus 8x plus 8 divided by 2, which is 4, squared, which is 16. And this factors perfectly to x plus 4 squared. Next, I have x squared minus 14x. I'm going to go ahead and add a negative 14 divided by 2 squared. That's going to give me x squared minus 14x. Negative 14 divided by 2 squared is negative 7 squared, which is 49. And this is going to factor perfectly to x minus 7 squared. So let's go ahead and solve an example using completing the square. So first, we have to make sure that our leading coefficient is 1, which for our example it is. Then we need to write the equation so that the constant term is alone on one side of our equality symbol. Next, I'm going to add, so I'm going to subtract 10 from both sides. Next, I need to add b divided by 2 squared, but I have to do that to both sides because remember we're working with an equation. So what I do to one side, I do the other. Okay, now I have x squared plus 8x plus 8 divided by 2 is 4 squared is 16 equals negative 10 plus 16. So I've got x plus 4 squared equals 6. Now how do I solve this? I'm going to go ahead and use the square root property. So I'm going to take the square root of both sides. So I have x plus 4 equals plus or minus the square root of 6. I subtract 4 from both sides. So I get x equals negative 4 plus or minus the square root of 6. So my solution set in this case would be negative 4 plus the square root of 6 and negative 4 minus the square root of 6. Let's go ahead and try this again. So I've got two examples here. Let's do the first one. My leading coefficient is 1, so I'm good to go. I've got x squared plus 5x. I need to move that constant to the other side. So I have x squared plus 5x equals 1. I have to add my middle term divided by 2 squared. This is going to give me x squared plus 5x plus, I'm going to go with 25 fourths equals 1 plus 25 fourths. This would give me 29 fourths. And over here is going to factor to x plus 5 square root of 2. I'm going to have to go ahead and take the square root of both sides. I have x plus 5 halves equals the square root of 29 over the square root of 4, which is going to be 2. Then I go ahead, and this is plus or minus, right? Because we're using the square root property. So I have x equals negative 5 halves plus or minus the square root of 29 over 2. And we could rewrite this as one fraction over our denominator. Remember that there are two solutions here. Let's work through our final example. I have 2x squared minus 4x minus 5. The first thing I'm going to have to do is divide by 2 because I need my leading coefficient to be a 1. Then I'm going to go ahead and move my constant to the other side. I'm going to add my middle term divided by 2 squared which is just going to come to 1. So I have x squared plus, x squared minus 1. This is going to factor to x squared minus 1 equals 5 halves plus negative 2 divided by 2 squared is 1. So this is actually going to be 7 halves. And now I can go ahead and use the square root property to solve. I've got x minus 1 equals plus or minus the square root of 7 over the square root of 2. I'm going to add 1 to both sides. I have x equals 1 plus or minus the square root of 7 over the square root of 2. X equals the square root of 2 over the square root of 2 plus or minus the square root of 7 over the square root of 2. So x equals the square root of 2 plus the square root of 7 over the square root of 2. Now I need to rationalize this denominator by multiplying by the conjugate. Well, the conjugate of square root of 2 is just the square root of 2. So we harness the power of 1 right here, and I'm going to get x equals 2. The square root of 2 times the square root of 2 is 2. The square root of 2 times the square root of 7 is the square root of 14. So here we have our fully rationalized solution.